So today we're doing a prereq for Algebra 2. It's graphing lines. I've taught this for years. A lot of kids struggle with graphing lines, and Algebra 2 is a graphing course. So we're just going to graph some lines today. And this is the mother function, graph y equals x. It literally says y is x. So no matter what I put here for x, and I like to use those points right there. That should be a positive one. Y is going to be the same thing. So if x is -1, so is y. If x is 0, so is y. And if x is 1, so is y. If you forgot how to plot points, which I noticed several of my students have forgotten how to do this year, to get to -1, -1, you go left 1 and you fall 1. 0, 0, 1, 1. Now, you only really need 2 points for a line. But this is y equals x. Okay? And it is the mother function for all lines, with the exception of the y equals a constant and the x equals a constant. Now, the standard form of a line is kind of odd. Sometimes it's called the general form too. It's ax plus by equals c, where, I'm off today, aren't I? Where a is a positive integer. It's not negative. Then you have slope-intercept form. We know that better as y equals mx plus b, where m is slope and b is the y-intercept. And you have vertex form. Now, vertex form is not something that is in an Algebra 2 book. I have never seen it actually taught, but there is a vertex form of a line, and the reason I'm choosing to teach it is because vertex form is so important in the concept of Algebra 2. The vertex of a form would simply be y equals a times x minus h plus k. So it's a little bit different here, but a is going to be your slope, and hk is a point on the line. That's all it is. A times x minus h plus k. And again, if you're an Algebra 2 teacher watching this and you're like, why isn't this dude using point slope form? It's because in Algebra 2, vertex form takes over. So I'm choosing to teach lines in vertex form. Plus I want to manipulate. Okay? Graph f of x equals -2x plus 5 using y equals mx plus b. So, I'm going to write down the mx plus b part. And I'm going to go ahead and just do a lineup process here. My slope is -2. It is not -2x, it's just -2, which means I fall 2 and I run right 1, because there's an understood 1 over everything. And my y-intercept is 5. Technically it's 0, 5. That's the coordinates. Now you start by plotting the y-intercept. And then you kick in your slope. You're going to fall 2 units and run 1. Or conversely, rise 2 and run left 1. See, not hard. Next one on this page is a convert f of x is 1/3 x minus 4 into ax plus by equals c. Now f of x is fancy for y. So let's do that substitution. Now, if you look at this form, the x's are on the left-hand side. Like see, over here, they're on the right. We're going to move over. And if you jump equality, you change your sign. So it's no longer positive 1/3 x, it's negative 1/3 x. Negative 1/3 x plus a y is now equal to a -4. Now, in standard form, a is positive integer. An integer is something like -1, -2, -3, 0, 4, 5, 6. It's whole. Okay, but it's a positive integer. Now, in algebra, I teach by doing opposites and doing easies. This is not an integer, but if I were to multiply it by 3, it would be. But if I do it to one thing, I got to do it to everything. So I'm going to multiply everything by 3 because the opposite of division is multiplication. And the 3's will cancel here. I've got to do this off to the side, but 3 times 1/3 is 1. Still have the negative x plus 3 times y. 3y is 3 times 4, -12. Positivity matters. So to fix that negative sign and make it positive, I just divide it and everything else by a -1. So now I have x minus 3y equals 12, and that is the standard form I was after, ax plus by equals c. A lot of Algebra 2 is about learning how to manipulate. All right, graph f of x equals -2 times x minus 3 using vertex form. So the form on vertex form is a times x minus h plus k. A lot of kids will tell you that h is -3. It's not, because the form has the minus sign. H is 3. Change sign, keep sign. K is -3. And what this tells me is, it tells me that there is a point on this graph at 3, -3. Pay attention to that, because often in Algebra 2, if you leave a set of parentheses, you will change its sign. The A is our slope. There's my slope. Fall 2, run 1. Or conversely, rise 2, run left 1. All right, now we have concepts of domain and range. Domain is your x values, traveling left and traveling right. The graph here will travel left forever. It will reach -infinity eventually, and it will run right forever. It will reach positive infinity eventually. The range is also fall forever, rise forever. The domain and range of any slanted line is -infinity to infinity. All right, there's some more conversion on here. Convert f of x as 3 times x minus 1 plus 2 into the following forms. Slope-intercept form. That's done easily by just doing the distributive property. So let's take our line. Remember, f of x is fancy for y. Let's kick in the distributive property. 3 times x is 3x. 3 times the -1 is -3. And then plus 2, but it's not quite there. We're going to have to add these two like terms. So y is 3x minus 1. That's slope-intercept form. That's mx plus b. Standard, which is ax plus by equals c. Now, we're going to work off of this one. So let me write down what I've got thus far. I have y equals 3x minus 1. And just like the one I did on the previous page, this belongs over here. So this becomes -3x plus y equals -1. And again, this guy right here is a positive integer. I can fix negativity by dividing everything by a -1. And that will give me a positive 3x minus y being equal to 3. And that is my general or standard form of that line. Moving forward, convert 3 times x minus 7 into vertex form. And this thing has a number of possible solutions. Okay. Vertex form again is y equals a times x minus h plus k, where h and k are some point that exists on the graph. Now, this is kind of like anti-factoring. So there's a 3 in front of that x, and I'm going to leave the x in the parentheses. And I'm just going to make up a number here. I'm going to put -1. And I don't know k yet, okay? But I know that the result has to be -7. So let's see what I've written. I have written 3 times x minus 1 plus a k. And 3 times x minus 1 is 3x minus 3. I need this piece right here to be -7. So -3 plus k must be -7. If I add 3 to both sides, k must be -4. And I know full well that a large number of students are going to struggle with this. It's about learning how to manipulate and find equivalence. But that is a vertex form of the same equation. They look exactly identical on a graph. They really, really do. Anywho, convert -2x plus 5 into an equivalent vertex form. So let's just do like we did the last time. And I'm not really trying to do things here. Like this time I'm going to do plus 2. I'm just making up a number and seeing what happens. Plus k. Remember, I need to be a plus 5. Let's go off to the side. Think about the distributive property. -2x minus 4 plus k is what I have. I need these two pieces to be a positive 5. So negative 4 plus k must be a 5, which means that k must be 9. So here's my vertex form. Negative 2 times x plus 2 plus 9. And again, this number was just a made-up number. That's all it was. It's just something I made up. I didn't think about it. I just put down a number. Now, don't do something silly and like put down a 20. Do little numbers. Do like 1s, 2s, 3s. Make them positive, negative. It doesn't really matter. Just make something up. It's not hard, but then again, I've done this a long time. Convert that bad boy into standard form. Standard form being ax plus by equals c. So the first thing we're going to have to do, and if you see notation like that, remember that's just a fancy formula for saying y, is we're going to have to invoke the distributive property. Negative 4 times x is negative 4x, negative times negative is positive, 4 times 2 is 8. And then we're going to combine like terms, because to write in standard form, you start with slope-intercept form. Now, the x's belong over here. That'll make it positive 4x plus y equals 13. And it's done. It's in the correct form. So that one was easy. The next one's going to be a little harder because there's fractions. We're still going to have to do some of the same stuff, though. We're still going to invoke that distributive property. A third of x is 1/3 of x. A third of a negative 6 is a negative 2. Oh, this one isn't too bad because what happened here? The 2's canceled. So y is 1/3 of x plus 0, which I need that 0 there. Because standard form, if you look up here, is equal to something. Okay? Now, we need the x's on the left out front. If you jump equality, you change your sign. And the issue here is that this number is supposed to be a positive integer. Well, the opposite of dividing by 3 is multiplying it by 3. And if you do it to one thing for purposes of equality, you do it to all things. Now, a negative third times a 3 is a negative 1. So negative x plus 3 times y is 3y. 0 times anything is 0. So negative x plus 3y is 0. But remember, positive integer. Divide out the negativity. X minus 3y is nothing. That is the equivalent standard or general form of that line, which was given to you in a vertex form, almost a point slope form. All right. 3 pages to go. Graph 4x minus 5y equals 10 by converting into slope-intercept form. This is what most kids do. You can also do this by finding x and y intercepts, and I'm pretty sure one of the slides covers this. But to convert into slope-intercept form, first off, you have to know what slope-intercept form is. Slope-intercept form is y equals mx plus b. Notice there is a singular y. There's not 5 of them. There's a singular y. But the first move is to put the x's where the x's belong. Negative 5y equals negative 4x plus 10. The next move is to make that a singular positive y, so we have to divide every single piece by negative 5. Now a negative over a negative is positive. I'm not going to write 0.8x. I don't need a calculator. 10 over 5 is 2. And there she is. She has a y-intercept of negative 2 and a slope of rise 4, run 5. Now you guys are juniors. I'm not going to spend every slide going into full detail on what things are. Your y-intercept is negative 2. Put a dot at negative 2. Rise 4, run 5. There's your 2 points to draw a line. And the domain and range of any slanted line is negative infinity to infinity. Easy peasy, lemon squeezy. Slide 7. Graph 3x minus 6y equals 12 by finding the x and y intercepts. So I got a little box here for you to write in. Like it's important. I'm pretty sure I even said bruh. Like bruh. On the x-axis, y is 0. So to find an x-intercept, let y be 0. On the y-axis, x is 0. So to find a y-intercept, let x equal 0. So think about that. On the x-axis, y is 0. On the y-axis, x is 0. That's how you find the intercepts. So for the x-intercept, it says y is 0. There's a y. It's going to become, wait for it, a frickin' 0. Now 0 times anything is itself, so now 3x is equal to 12, which means that x is 4. Now my x-intercept has a value of 4 when y was 0. So 4, 0 is an x-intercept. For the y-intercept, it says on the y-axis x is 0, so to find a y-intercept, let x be 0. So I see 3, I see an x, that x becomes a 0. Minus 6y is 12. This is nothing, okay? It's nothing. Divide out the negative 6, and I know that y is negative 2 when x was 0. And there's my line. Easy peasy Japanesey. Last page. Write the equation of the given line in lots of different forms here. The first one is slope-intercept form. Slope-intercept form being y equals mx plus b. This is not a high school math standard. This is a middle school standard. So you should be good at this. Now let's think here. We fall 4 and we run 3. My slope is negative 4/3. This is the y-intercept. B is 4. So my slope-intercept form is negative 4/3 x plus 4. Super easy. General form, that's the tough one. ax plus by equals c. Now, the x's are on the left. We're going to shift the negative 4/3 over. It's going to become positive. It goes in front of y. If you jump equality, change your signs. And it's still equal to the 4 that was on the right. I'd simply move this guy over. This guy didn't move. Issue. That is supposed to be a positive integer. It is not. It is a rational number. It is a fraction. But there's a division of 3. And you fix division of 3 by 3ing. And if you 3 one thing, you 3 everything. So we 3 all 3 pieces. 3 times 4/3, the 3's cancel. We have 4x. 3 times y plus 3y. 3 times 4, 12. Now the vertex form on this one's going to be a little fun. Yeah. So let's start with our slope-intercept form. And we're going to pull the negative 4/3 away from x. And then we're just going to make up a number. You know, look at your hand. Pick a number. 2. Going with 2. Do I want it to be positive? Do I want it to be negative? I want it to be negative. And then I have this k value that I have to have. Okay, I need to know what this k value is. So let's see what I've written so far. I've written negative 4/3 x plus 8/3. And what do I need? I need a plus 4. Don't forget you have the plus k. So it turns out that 8/3 plus k must be a 4. We're going to subtract 8/3. K is 4 minus 8/3. We're going to revert back to 5th grade. We're going to make this 4 a 12/3 because 12 over 3 is 4. And then we're going to figure out what 12/3 minus 8/3 is, and amazingly enough, we're going to get 4/3. So, it turns out that this is k. So I can finish my vertex form. It's y equals negative 4/3 of x minus 2 plus 4/3. And, you know, if you're a teacher watching this video, like, why did Milbrath do this? Milbrath did this because a big deal is learning how to manipulate for a desired outcome. So that's why I'm having you kids do things in vertex form, even though nobody else does that with lines, because you need to learn how to manipulate. That's what it's about, manipulation. And there you go. There is a prereq P1. Hope you enjoyed. You probably didn't.